Welcome to Lesson 2 of Section 12 of the BJCP training program by the Brewers Anonymous Homebrew Club. We are starting our discussion on beer characteristics with the two physical characteristics noted in our study guide, body and head retention. All right, here we go. When discussing the body of a beer, we are generally talking about the tactile feel you get on the tongue, in the mouth, and even in the finish of the beer. And that comes from the fullness of the beer. And that can be further broken down to the viscosity of the beer. Is it thin and watery, or is it heavy and thick with a bit of a coating, clinging character? And texture. Is there any creaminess to it? If so, to what extent? Or is this watery as well? The body character also comes from mouthfeel. Is there any astringency? And that's the dry, puckering sensation you can feel on your gums and sides of your mouth. It's been likened to sucking on a tea bag, and I can't say I know what that is like exactly because I've never done it, but I think I can imagine that sensation and what it might feel like. Alcohol warmth is also a contributor to mouthfeel. Is the alcohol level high enough to feel in the form of a heating sensation in your mouth and possibly following down into your chest as you swallow? And carbonation as well is part of mouthfeel. How does the level of carbonation enhance and complement everything? Is it light and subtle, nearly flat, that would lend to a more luscious texture of a heavier bodied beer? Or is it highly carbonated and spritzy, adding a carbonic bite and opening your tongue and taking in more of the crisp, clean character of that beer? There's a few factors that contribute to all of these sensations in the body of beer. Dextrins, for instance. In the case of low dextrin levels affecting the body of the beer, that might be caused by a low saccharification temperature. This goes right along with the details we discussed in the wort production section. Lower mash temperatures produce more fermentable worts. Higher temperature mashes create a more complex and slightly less fermentable sugars. It can also be caused by the use of completely fermentable adjuncts. The best example of this is corn sugar. Corn sugar is near completely fermentable, and when it's used to increase our starting gravity, the thinner our beer will likely be due to the large amounts of simple sugars being fully converted during the fermentation. And using highly attenuated yeast will also contribute to low dextrin levels. The more efficient the yeast are at fully attenuating all the sugars it possibly can in fermentation, the less full-bodied the beer will be. Proteins also help contribute to a body of a beer. In terms of low protein levels that can be affecting the body of our beer, low protein levels can be caused by excessively short protein rest or excessively long protein rest steps in the mashing portion of our wort production. It can also be caused by the protein rest steps being performed at a too high or too low of a temperature. There are a couple other notable factors that lend to a perceived thinner body in beer. One is high alcohol levels. High alcohol levels lighten the body of a beer, and this is due to ethanol being less dense than water. A high carbonation level can also contribute to a lighter bodied feeling beer. The CO2 decreases the sensation of the fullness of the body from the effects of the dissolved gas, reducing the overall density of the beer. There are some remedies to light-bodied beer. Now, this is all after the fact, keep in mind. These are improvements that we'd have to make on the next time we brew this beer. There's not much we can do when the beer is done, at least not that we need to know in terms of our exam. First, we can add dextrin malt to our grist. As the name implies, dextrin malts add dextrins to the wort. We can add some unmalted flake grains like flake barley, flaked oats, or flake wheat. These help increase the protein levels in our wort. Taking a look at body appropriateness in different beer styles, light body beer is appropriate for American lagers and lambics as an example. It's not appropriate in barley wines, Scottish ales, and doppelbocks, however. Now on to the subject of head retention. This is a visual characteristic of the beer. Ideally, according to our study exam material, good head retention should hold for at least 1 minute before collapsing half its initial height. The beating of the foam should be uniform and tight, and it should leave a lacing on the glass as it's being consumed. You've probably seen this. If you don't know the term, it's when you take a sizable sip of beer and put down your glass, and where the head was, kind of the top area, is a thin line on the glass, and it keeps putting additional lines of foam on the glass after each sizable sip. That's called lacing. Good head retention is promoted by several factors. Starting with isohumulins. These come from the alpha acids in the hops during isomerization during the boiling phase of our brew process. A high or original starting gravity also helps contribute to good head retention. Moderate alcohol content also contributes to good head retention, or, I think better said, prevents poor head retention, because the higher the alcohol level gets, the less head retention we tend to have on beers. The amount of dextrins in the finished beer help influence the head retention. And high and medium molecular weight proteins also aid to head retention. These help stabilize a foam, creating a lasting head on the beer and contributing to its appearance. Each of these particulars in head retention are style dependent. Some styles, it's important to the overall character of the beer. To others, it's not so much. With so many styles, this is a detail that's hard to prepare for in the exam. It's hard to memorize this one particular detail for over 100 styles of beer, and it's not going to get us much of a return on our efforts. We very likely will not get a single question about head retention. Not saying it's impossible, I'm saying it's unlikely. So in my opinion, and just my opinion here, but I think it makes sense, it's best to leave this particular detail to the open book allowance of this entrance exam. If you get that one question on head retention for a particular style, take the time to look up what the answer is rather than memorizing every single style and its head retention. That's really not going to gain you any value. Brewers can do some things to improve head retention in a beer when it's needed. They can adjust the length and temperature they use in the protein rest step of the mash, and adjust their grist with amounts of adjuncts like flake wheat and flake barley. A couple more things that can affect head retention. Fatty acids carried over from the trub, and dirty glassware can negatively affect head retention. Both of these will reduce the surface tension of the beer, and the foam and the bubbles will fall much quicker than without these conditions. Head retention is style specific, as just mentioned. Styles that are expected to exhibit good head retention include German Pils, wit beer, Belgian blonde ale, and styles where a lack of head retention is expected include Eisbach, Imperial Stout, and English and American barley wines. All right, that wraps up the physical characteristics we need to know for our exam. Now on to the individual off flavor and aroma characteristics, and that all starts in the next lesson. I will see you there.